Welcome to Interstellar Odyssey, Top 10 Challenges. Ever since the dawn of humanity, we have looked up at the night sky and wondered what lies beyond our reach. The stars, those distant specks of light that twinkle in the vast cosmic darkness, have been the subject of our dreams, our myths, and our scientific inquiries. But what would it take to actually journey to them? To cross the unimaginable distances and venture into the unknown? The answer is not just about technology or resources. It's about overcoming some of the greatest challenges that we, as a species, have ever faced. Over the next few minutes, we will take you on a journey to the stars, exploring the top 10 challenges of interstellar travel, from the technical difficulties to the psychological implications, from the energy requirements to the cosmic radiation. We will delve into each of these obstacles, unpack their complexities, and discuss potential solutions. So buckle up and get ready for an interstellar odyssey like no other, and you won't believe what's at number 1. Let's get started with the enigma of interstellar travel. Have you ever gazed at the stars and wondered what it would take to journey to them? It's a question that has captivated mankind's imagination for generations. The very idea of interstellar travel, of crossing the vast cosmic distances to reach other stars, is an enigma that both baffles and enchants us. The universe, in all its majestic splendor, is a puzzle that we've barely begun to piece together. And at the heart of this puzzle lies the concept of interstellar travel, a concept that seems more akin to science fiction than reality. Yet it's a concept that scientists, engineers, and dreamers alike are tirelessly working towards making a reality. This is not merely about exploration or the pursuit of knowledge. It's about survival, expansion, and the innate human curiosity that drives us to push boundaries and explore the unknown. It's about our future as a species. Yet, the journey to the stars is riddled with challenges. We're not just talking about technological hurdles, but also about confronting the fundamental laws of physics, the harsh realities of space, and the limits of our own biology. In our quest for the stars, we face 10 major challenges. Over the course of this video, we will delve into each of these obstacles, unpacking their complexities and exploring potential solutions. But before we can take a single step in that direction, we must first understand the hurdles that lie ahead. Starting at number 10, we have the challenge of communication delays. In the vast expanse of space, distances are so enormous that even light, the fastest thing in the universe, takes time to travel. This is a significant hurdle for interstellar communication. A message sent from Mars, for example, can take anywhere from 3 to 22 minutes to reach Earth, depending on the planet's positions. Now imagine the time it would take for a message to travel from a star system light years away. Real-time communication as we know it would be impossible. This delay complicates mission control, as any command sent from Earth would take an incredibly long time to reach the spacecraft, and just as long to receive a response. So, if we are to venture into the cosmos, we must find a way to deal with these long silences. Moving on to number 9, let's delve into the psychological impact of long-term space travel. Imagine, if you will, being confined to a small space, cut off from the world as you know it. The isolation alone is daunting, but combined with the vast emptiness of space, it can be downright terrifying. Our brains are wired for social interaction, for connections, for the hustle and bustle of life. In the void of space, none of these are present. Now consider the effects of living in such confined conditions for prolonged periods. The strain on mental health can be immense, leading to a variety of psychological issues such as anxiety, depression, and even cognitive decline. The simple act of seeing the same faces day in and day out, with no new experiences or stimuli, can have a profound effect on an individual's mental well-being. The human mind was not designed for such solitude, making this a significant challenge to overcome. At number 8, we have the development of life support systems. Picture this, a journey across the stars that spans decades, maybe even centuries. How do we keep our intrepid explorers alive and well during such an epic voyage? We're talking about a system that doesn't just provide air to breathe and water to drink, but one that can also recycle waste, grow food, and even simulate gravity to keep our astronauts healthy. It's a bit like trying to build a mini Earth inside a spaceship. But it's not just about survival, it's about quality of life too. Imagine being cooped up in a tin can for 100 years with nothing to do but stare at the stars. We need to create an environment that is not only habitable but also comfortable and stimulating. After all, we are human beings, not just cargo. Creating a self-sustaining ecosystem in a spaceship is no easy task. On to number 7, we face the dangerous threat of cosmic radiation. Now, cosmic radiation is no ordinary threat. It is a silent, invisible, and constant danger that could severely impact the health of interstellar travelers. Think of cosmic radiation as microscopic bullets constantly flying around in space. These high-energy particles originating from the sun and other celestial bodies can penetrate deep into human tissue, causing substantial damage. The long-term exposure to cosmic radiation could lead to a plethora of health issues, ranging from cataracts and cancer to damage to the central nervous system. Shielding a spacecraft from this omnipresent threat is a daunting task. Traditional shielding materials like lead are too heavy for space travel, and lighter materials can produce harmful secondary radiation. Innovative solutions like magnetic shields or radiation-resistant materials are being explored, but we are yet to find a foolproof solution. This invisible threat could prove fatal to interstellar voyagers. Sitting at number 6 is the issue of spacecraft durability. Picture this. An interstellar spacecraft is not just a vehicle, but a tiny, self-contained world. It needs to be robust enough to fend off the unforgiving vacuum of space, resist micrometeoroid impacts, and endure the constant bombardment of cosmic radiation. It's a bit like designing a car that can withstand a tornado, hailstorm, and earthquake all at once, for years on end. Now, imagine the wear and tear on the spacecraft systems. Every component, every bolt, every wire must function flawlessly for decades, maybe even centuries. There's no interstellar 8AA to call for a quick fix. It's all on the spacecraft's automated repair systems, which themselves need to be as durable as the rest of the ship. So, you see, building a ship that can survive the rigors of interstellar travel is a monumental feat. It's not just about reaching the stars, but doing so in one piece. Halfway through our list at number 5, we encounter the astronomical energy requirements. Imagine the energy your car uses in a lifetime. Now multiply that by 1,000,000, 1,000,000,000, and you're still not even close to the energy required for interstellar travel. We're talking about quantities so immense that they dwarf our current energy production capabilities. The challenge lies not only in generating this colossal amount of energy, but also in storing it. Traditional methods like batteries or fuel cells would be impractical due to the sheer volume required. Current nuclear power technologies do offer a glimmer of hope, yet they also come with their own set of complications. Moreover, energy conservation is a crucial aspect to consider. Every single operation, from life support systems to onboard scientific equipment, would need to be meticulously optimized to minimize energy consumption. Powering a spacecraft to the stars requires energy on a scale we can barely comprehend. To put it simply, we're not just reaching for the stars, we're reaching for a power source that can take us there. At number 4, we have the development of advanced propulsion technology. To reach the stars, we'll need to create propulsion systems capable of accelerating a spacecraft to a significant fraction of the speed of light. This is quite a tall order. Currently, our fastest spacecraft would take tens of thousands of years to reach even the nearest star. To traverse these mind-boggling distances in a reasonable time frame, we would need to achieve speeds that are currently beyond our technological reach. Concepts like antimatter propulsion, nuclear pulse propulsion, and even light sails propelled by powerful lasers are all under consideration. However, each of these methods presents its own unique challenges. Antimatter, for instance, is incredibly difficult to produce and contain. Nuclear pulse propulsion could have significant environmental impacts. Light sails would require incredibly powerful lasers that we simply don't have yet. Propelling a spacecraft across the vast cosmic ocean is no small task. Coming in at number 3 is the mind-bending problem of time dilation. Now, time dilation is a fascinating yet perplexing consequence of Einstein's theory of relativity. Simply put, it's the idea that time can stretch and slow down for someone moving at near-light speeds compared to someone who is stationary. Imagine this. If we could zip around space at speeds close to light, time would pass slower for us on the spacecraft than for those watching us from Earth. We could return from a 5-year space journey to find decades or even centuries have passed on Earth. It's like a cosmic version of the age-old tale of Rip Van Winkle. While this might sound like a fantastic way to time travel into the future, it presents significant challenges. How would we synchronize communication between our space travelers and a rapidly aging Earth? How would we manage the psychological impact on our astronauts? Time dilation isn't just science fiction, it's a very real hurdle for interstellar travel. Our runner-up challenge at number 2 is space navigation. Picture this, you're on a road trip, you've got your GPS set, but suddenly you find yourself lost in a vast, uncharted wilderness. Now, amplify that feeling by 1,000,000, and you've got a taste of the challenge of navigating in space. In the vast expanse of the cosmos, there are no road signs or landmarks. Navigating through the stars requires pinpoint precision and advanced technology to avoid countless obstacles. These obstacles are not just planets, asteroids, and black holes, but also microscopic particles that can cause damage to the spacecraft at high speeds. Accurately reaching the destination star system is another grand challenge. The stars are not stationary, they're constantly moving. Even if we can calculate their position accurately today, by the time our spacecraft gets there, the target star could be in a completely different location. Steering a course through the galaxy is far more complex than any earthly navigation. And finally, the #1 challenge of interstellar travel is the sheer vastness of space. This vastness is not just inherent in the grand scale of the cosmos, but in the mind-boggling distances that separate the stars from one another. Let's consider our closest stellar neighbor, Proxima Centauri. It's roughly 4.2 light-years away. Now, a light-year is the distance light travels in a year, which is nearly 6 trillion miles. So, Proxima Centauri is approximately 25 trillion miles away. To put that into perspective, if you were to hop in a car traveling at a steady 60 miles per hour, it would take you 48 million years to reach it. With our current technology, the fastest spacecraft ever launched by humans, the Parker Solar Probe, travels at a blistering 153,000 miles per hour. Even at this speed, it would take us 6,800 years to reach Proxima Centauri. These immense distances are a daunting challenge for interstellar travel. They demand a level of technological advancement that is currently beyond our reach. Yet they also inspire us. They compel us to push the boundaries of what we believe is possible. They force us to innovate, to dream, and to reach for the stars, literally. The vastness of space is our greatest obstacle, but perhaps also our greatest inspiration. So there we have it, the top 10 challenges of interstellar travel. We've journeyed through the enigma that is the cosmos, grappling with communication delays that stretch across the vast expanse of space. We've delved into the psychological impact of such long-term isolation and the significant challenges of maintaining life support systems in the harsh conditions of deep space. We've navigated the dangers of cosmic radiation and the immense need for spacecraft durability. We've explored the staggering energy requirements and the advancements in propulsion technology necessary to propel us through the stars. We've grappled with time dilation, the strange yet fascinating consequence of traveling at near-light speeds. We've charted the complexities of space navigation before finally staring into the abyss of the vast distances that separate us from the nearest stars. Yet, despite these challenges, we stand on the precipice of a new era. The future of interstellar travel is being shaped right now through ongoing research and technological developments. Scientists and engineers are working tirelessly to devise innovative solutions to these seemingly insurmountable problems. Propulsion technologies are being reimagined with concepts like nuclear propulsion and matter-antimatter reactions. Researchers are exploring ways to shield spacecraft from harmful cosmic radiation and developing durable materials that can withstand the rigors of space travel. Efforts are being made to create sustainable life support systems that can support human life for extended periods. And let's not forget the fascinating work being done in the field of artificial intelligence, which could revolutionize space navigation and even address some of the psychological challenges posed by long-duration space travel. These are exciting times we live in. The stars may seem out of reach today, but the relentless march of progress is slowly but surely closing the gap. Interstellar travel remains a distant dream, but every dream begins with a single, daring thought. Until next time, keep looking up and daring to dream. Before we end this cosmic odyssey, we'd like to remind you that our journey together doesn't stop here. If you've learned something new from this video, or it sparked a curiosity about the cosmos that you didn't know you had, then please give this video a like. It supports the channel and helps us bring more content like this to you. We'd love to hear your thoughts about interstellar travel. Do you think we'll conquer these challenges in your lifetime? What do you think is the most significant hurdle? Or maybe you have a unique solution to one of the problems we've discussed. Whatever it is, share your opinions in the comments below. We'd love to start a conversation about the future of our journey among the stars. Don't forget to subscribe and press the bell icon. You'll get notified whenever we release new content like this, and it's the best way to stay updated on our latest interstellar discussions. And if you know someone else who's as fascinated by the cosmos as you are, don't hesitate to share this video with them. The more minds we have pondering the mysteries of the universe, the sooner we can unravel them. So until next time, keep looking up, keep daring to dream, and keep reaching for the stars. We'll see you on the next step of our interstellar odyssey.